video to you. Okay. 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 This is last week's document material. So first of all, you installed your crypto wallet MetaMask, and then you registered your MetaMask into a course website, and then you get a some small amount of is, and also you get a small amount of ERC20 tokens. And you should import the token contract into your wallet because wallet cannot recognize new token type. So you should register, import your token type, the new token type, and then some of you sent a small amount of ERC20 tokens to other students and check the Blog Explorer in order to confirm whether your transaction was successful. So we explored Blog Explorer a lot, and then we swapped is to stablecoin USDC in Uniswap. Uniswap is very popular and it is the most famous DEX in crypto space. And you can exchange any kind of tokens or coins to other tokens or coins. So if you succeed in swapping your Ether to stablecoin, you may get your stablecoin for the first time. So stablecoin is very popular nowadays because many countries like United States or Korea uh, is starting to issue stablecoin and make a law about issuing stablecoin. Even a company, even though it is not a bank or it is not a financial companies. So maybe big companies like Naver or Kakao can issue their stablecoin in the future, in near future. So stablecoin is getting very popular. So, but most people don't get their own stablecoin, but you get stablecoin in your wallet. And we missed uh, buying NFT. So if you have time, you can buy an NFT in OpenSea. OpenSea is the most popular NFT marketplace, and you have small amount of ETH in base network. So you can buy very cheap NFT by yourself. And then you have to import new NFT type in your wallet like this. And the last practice is setting up a blockchain development environment. So today's we will start from this section, setting up dev environment. I already shared this document, so you have to open this document and follow up this lecture. Who finished setting up dev environment? Can you leave the message in the chat box? Yes, video will be shared later. Is anyone finish setting up blockchain development environment? No? No one? Okay. So we will start from here. Uh, Blockchain environment like Base network or Ethereum network and Kaya Solana, you have to pay for gas fee to process your transaction. So it is not a free. It is not a free. So uh, when you develop your application, you have to pay for small amount of gas fee. So it's not it's not comfortable. So usually we use testnet. Every blockchain platform provides their own testnet. So Base Network has their own testnet called Seporia Base Testnet. So if you want to connect to Seporia testnet, you have to register that network into your MetaMask. So open your MetaMask like this and add network. Uh, In this list, you cannot see base Seporia testnet, so you have to manually add base Seporia testnet with adding network. So you have to put this information with this network name, base Seporia testnet, and RPC URL, and this one, and chain ID is this. And also currency symbol is and big block explorer and this one. And then you put store and you may see base separate testing like this. Okay. And then uh, you have to get some amount of is in testnet. As you can see, I have zero point zero 0.03 is. It is free. So you have to connect process service. There are many process service. This service give you free testnet is like this. I recommend Alchemy Posset because uh, they don't require login or any other information. So copy your address and then put your address into the box and send me. Okay, okay. I'm not a robot. Okay, it's done. I will get zero point 0.1 base separate is, but it takes time. Maybe a few minutes or a few hours. I don't know. So you have to wait for a minute. Oh, I get zero point 0.1 is right away. So you will get this separator testnet is. Okay, so we prepare to develop blockchain application in the testnet. Okay, let's step. Next step is learning what smart contract is and what is the feature of smart contract and what is the what is new in Solidity programming. Smart contract is the name of program in blockchain. So when you say I developed a contract in Solana, it is called I developed a new program in Solana. Why did we call this program smart contract? It is very similar to contract because when we write a smart contract and deploy smart contract into the blockchain, we cannot modify. Because as I said, blockchain is immutable. So uh, when we write something in blockchain, we cannot modify. So and also when you deploy your smart contract into blockchain, if someone call that smart contract, the smart contract will automatically run without your permission. So it is very similar to contract in real world. So it is called smart contract. And there are some languages to develop smart contract like Solidity or Rust. But nowadays, Solidity is most popular because it is oldest one, and Ethereum support Solidity language a lot. So many programmers, many crypto developers already developed Solidity program and shared this program, and someone newbie in Solidity programming uh, reuse their code. So Solidity is the most famous and popular smart contract language. I listed some different features from traditional programmings in smart contract. So smart contract cannot be modified and tempered. It means you cannot upgrade your smart contract. It is very weird to the programmer. So how can we update, upgrade our program in blockchain? You have to deploy new smart contract to the blockchain. But in this case, new smart contract is not updating your old one. Instead, new smart contract will be deployed, and then that smart contract will get new address. It means anyone can access old smart contract, even though you update that smart contract. So it's very weird, but it's the true in blockchain world. So when you develop your smart contract, you should be very cautious because if your smart contract has some bug or errors, you cannot modify. You have to redeploy your smart contract. And next one is smart contract will run automatically without your permission. So, uh, so there are tons of smart contracts in the world, like in Ethereum or Solana or Kaya. So if you know the smart contract address and the function names, you can call that function of the smart contract without any permission. So it's very interesting features. Smart contract has these features: automatically running with users' transactions. So we can combine uh, several smart contracts with our smart contract. So it is composability. when we develop our smart contract, we don't need to develop whole things. Whole things. We don't need to develop the whole things from the ground because there are many smart contracts that has good functions. So we can reuse their functions and we can call that functions in our smart contract. And also code is transparent and public. I In the last lecture I so I we explored either scan, base scan, and then we saw the code of smart contract. Usually, when we put our smart contract, we verify our code into base scan, like Block Explorer, and then Block Explorer reveals the source of smart contract. So it is very transparent and very public. And there is no single point to execute the smart contract. Whole nodes of blockchain will run that smart contract. So it is very similar to cloud system, but there is no company to run this nodes blockchain. So it is very decentralized cloud system. It's very similar. And good point is if you developed a very nice smart contract and then you deployed that smart contract in the blockchain, you don't need to pay more. Users should pay for calling that smart contract as a gas fee. So Mm, but when but in traditional cloud system, you have to pay for monthly subscription fee of cloud computing or data center. But in blockchain, you don't need to pay for more money after deploying your smart contract. So it's very interesting feature. And smart contract is secure because of blockchain. So anyone can modify your smart contract, but it is vulnerable because the source code is open and anyone can see your code. So hackers may find out the vulnerability of your smart contract. So in crypto world, there are a lot of accidents. There are a lot of this kind of hacking or scamming, a lot of. So when you're developing your smart contract, you have to be very cautious. And then after developing your smart contract, you have to audit your smart contract with other specialized auditing companies. So that auditing company will check the vulnerability of your smart contract, but it's very expensive. Okay, so I will not teach Solidity to you. You can learn Solidity in other website. There are many websites to teach Solidity. Okay, today we will develop very small, very simple Solidity program with Remix. So let's open the Remix. It is Remix. Remix is a web-based virtual environment to develop Solidity. So, as you can see, it's very similar to other tools like Visual Studio, but it is web-based, so you don't need to install anything. Anything. So, you just open the site, And then contract. Maybe you have one, two, three sample Solidity program. I wrote some Solidity program into it. Yeah, Remix is very convenient tool because when you develop your smart contract, the most difficult part is testing your smart contract in blockchain environment because you have to confirm, you have to deploy your smart contract into blockchain with your wallet, and you have to confirm, and you have to pay for gas fee. So you have to do a lot of things to test your smart contract whenever you test your smart contract. So uh, it's very yeah, not an easy environment to develop something. But Linux has their own simulated environment of a blockchain. So you don't need to deploy your smart contract into real blockchain. You can test all your smart contract in the Remix. So uh, let's write your first Solidity program. Yes, copy this program, simple store easy, and then make your new file. Okay, copy this one and remix new file. Okay, simple storage 2 JSON and copy that. That's it. And then you have to compile this source code. Solidity compiler, you have to uh, you have to assure the compiler version is the same like this. So you can choose the compiler version, and you specified your compiler version in the source code point 8.30, so same, and then compile. Okay, we finished. And you can see, I can see the learning environment. This is learning environment, and uh, you can see many other virtual blockchain environment in this. First, we test our Solidity in Remix VM. So this is my address, and so this environment provide many simulated address, and I have already 100 is in this address, and then you can deploy. Okay, this is console box. It's a success, and this is deployed contract and expand. Okay. As you can see, you can execute the function in this panel. In source code, there are just two functions, set value and get value. It looks very simple, but it's very important. When you write some variable value, it is stored in blockchain. So if you want to call set value function, this function will change blockchain state. So you have to send a transaction to the blockchain when you call set function. Okay, set value. Currently value is 0 and I can set, okay. So the value is changed. It's very simple. It's very simple, but uh, most smart contract is the expansion of this simple smart contract. So, hmm, did you test this smart contract in Remix? Okay, okay. I will give you a little time to finish this first practice. So, this is a smart contract address. So you can copy this address and you can see your address like this. But when you deploy again, you will get another uh, smart contract deployed in virtual environment like this. So these are two different smart contracts in blockchain. You can think the source code uh, of smart contract as a class, and the deployed smart contract in blockchain is kind of instance of this class. So whenever you deploy a smart contract, your smart contract will be run in blockchain. So these are two different smart contracts with the same source code, but two different. Okay. Okay, move on to next uh, part. Simple stories is very simple example of a smart contract. But next one is ERC20 standard token. If you can write ERC20 tokens by yourself without any library, you can write any kind of smart contract because ERC20 contain has uh, a lot of features that has that you can learn in Solidity language. So first of all, I'd like to introduce EIP and ERC. EIP means Ethereum Improvement Proposal. If anyone want to propose new technology or new improvement in Ethereum, they have to write some proposal and then send this proposal this side. And uh, in the community of Ethereum, many developers and contributors are discussing about these proposals, and then they decide to accept new proposal or not. So this is EIP, and there are many different types of EIP: core development or networking and interface, and ERC. ERC is uh, smart contract interface standard. So if when you develop smart contract, usually you have to follow this ERC standard because they define the interface to develop something. So token standard it is ERC20 and ERC721 is the standard for NFT. And 20 you can see the interface, standard interface. We need these kind of functions. Total supply, balance of transfer, blah 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 blah. And when you write some uh, functions for this interface, you can develop your own ERC20 tokens. This is the sample. No, no, it's interface, and this is the sample of ERC20 tokens. So you can copy this code and then add new file. Yes, this is my token contract implementing ERC20. I'd like to explain a little bit about this implementation. Uh, the balance variable is the key of ERC20 tokens. It is dictionary structure, data structure. So as you can imagine, this data structure balance contains the mapping between address and the amount of tokens. So when when this smart contract mint some tokens to some address, this contract just write that fact in balances data structure. So as I said, when you send some token to others, that tokens will not go to their address. Just the contract write that fact, that change in their data structure balances. So transfer function, as you can see, transfer function, it just change this balances variable, the amount of tokens. That's it. Very simple. That's it. And mint function and bond function, these are also changing the state of balances. Okay. And then you can compile my token smart contract and deploy. When you deploy this smart contract, constructor needs initial variable. So you have to put initial variable like Web3 add KAIST token and WKT. It's a symbol of your token and max supply. Max supply maybe 1 million. Okay. And then transact. So contract is created in this Remix VM and you can see contract address is D4FC blah blah blah. And as you can see D4F, this is your smart contract deployed in Remix VM. And you can see all functions of this smart contract in these tokens. Total supply, 0, current 0. And symbol, WKT owner, and name. Max supply, 1 million. I will explain decimals later, 18. Okay, and mint. Copy this address. This address is balance is maybe zero. So you can check balance of functions like this and zero. And first of all, we have to mint maybe 22,000 and 20,000. Okay. Transact. Okay. And then check again and 20,000. So it's very easy to test our smart contract. So Remix is very convenient environment because we don't need to develop the front end side to connect to smart contract. We can just call every functions of smart contract in this panel. If you want to simulate another user, you can change the account to another. And then if you want to mint your tokens in this account, so call the mint function and 20,000 and transact is failed. As you can see, why it is failed. Let's see the source code. It is mint function. In the mint function, you can see modifier. It is called modifier only owner. And we defined only owner function modifier in this side. And uh, whenever mint function is called, first of all, the function checked the modifier only owner. And then, uh, sorry. And then this modifier check, the transaction sender is the same as the owner. Who is owner? Owner is the address of address address where the smart contract is created. So when we send transaction to create a smart contract, that address is the owner. So just only an owner can call mint function and also burn function. Yeah, only owner just call mint and burn function. So it is the way to control or restrict to call some functions by using modifier. Okay, so maybe you run this smart contract in your Linux. Maybe it's not that difficult. I- Is there any problems? If you have any problems or issues, you can leave some message in the chat box. Okay. So the code is not that difficult. It's very intuitive. So the difficulty of developing smart contract is not a grammar, programming grammars. It's not that difficult to develop a smart contract, but the difficult part is we cannot modify, update easily. So if you miss some small part in your smart contract, it may it may it may make a big problems. And also, most functions are related to financial things. For example, transfer functions will transfer some tokens to others. So it is related to money, real value. So it is not a writing comments or posting some document because it is financial functions. Most smart contract functions are related to financial things. So when you if the smart contract has small uh, hole or vulnerability, the small mistakes become very big catastrophe. Okay, uh, this is a ERC20 implementation from the ground, but you don't need to write whole things. We have a library, many library, especially Open Japanese library is most popular. So this is Open Japanese site, and you can see many standard smart contract that they wrote and many developers already used and already deployed. So it is verified or validated by other users, other developers. So you have too many different type of contract. Yeah, these are contract. Uh, okay, okay. Oh, okay. Contracts. Yes, 20. Uh, if you want to create your ERC20 tokens, you just all you have to do is writing these five lines. Very simple. Because this code inherits ERC20 library of OpenJetBrains, which is implemented whole functions of ERC20 interface. Okay, yeah. Mm. Okay, in ERC 721, they already have standard ERC 721 implementation. You can just write this code and you will have your own NFT smart contract. So copy this code and then uh, put this code into remix. Yeah, gold token. So these are my ERC20 tokens called GLD token. Yeah, very simple. So, mm, so developing tokens is not difficult. That's it. That's it. The difficult part is operating these tokens as a business. Okay, and compile this code and then uh, deploy. Initial supply maybe 10,000 and deploy. Okay. And then I get GLD token. Same functions, except mint and burn. Okay. Name and symbol. Okay. Okay, that's it. So I recommend using OpenJetBrains smart contract. When you start developing smart contract, you have to reuse already proven smart contract like OpenJetBrains. They provide many different types of smart contract, like tokens or governance protocol, governance smart contract, voting smart contract. So you can just find out suitable smart contract in OpenJetBrains and then just copy that smart contract and change small part of that smart contract and deploy the smart contract because it is already proven. ERC20 standard is just a standard interface to implement tokens, fungible tokens. But there are many different ways to utilize these tokens. So in crypto world, there are many different types of tokens, such as utility tokens. Many, maybe most tokens in crypto are utility tokens. It means the token is used as a utility in that service or in that platform. And governance token is the voting tokens. When you decide, people decide something in a crypto project, they usually make a voting and then decide something. So it is governance. So usually project issued their governance tokens and the people who want to participate in governance, they will buy governance tokens and then vote for some proposals. So that is governance tokens. And stablecoin. Stablecoin is also stable, also ERC20 token because it is just tokens, but the token price is fixed as $1 or one Korean won. And meme coins. Meme coin is kind of, I don't know what to say. Meme coin is kind of marketing coin, marketing tokens. I don't know, but uh, there is no utility. There is no utility. It's just for fun. So people just issue their meme coins like Pepe or Dochi, and someone buy that coin for something. I don't know the purpose, but someone buy, and the coin has the price. So that is meme coins. And wrapped tokens is wrapping native coins like ETH or Bitcoin. So the platforms has their own native token, and this native token is different from ERC20 tokens. So if I want to exchange our native token like ETH to other ERC tokens, it's a little bit difficult. It has a lot of works to do. So usually, usually, in some service is wrapping is to wrap this, and wrap this is kind of ERC20 tokens. So we can use WS in Uniswap to exchange ERC20 tokens. Okay, in this section, we will implement stablecoins. How can we develop stablecoins? It's just ERC20 token. So you can just copy this code and then put this code in the remix, my stablecoin. As you can see, this my stablecoin inherits ERC20 smart contract from OpenJetFree and add two more functions, mint and burn. Actually, ERC20 OpenJetFree ERC20 standard has underbar mint function and underbar burn function. So we just use these private functions for public mint functions. Okay, so mint and burn. Mint function will be called when someone send their fiat money, like 100 USD real money, to these stablecoin companies, and then this company will call this function, mint function, to the user's address. And the user if user want to get back their real money, 100 USD, they will call fund function with their stablecoin, 100 stablecoin, and this company will return 100 USD to the user. But let's think about this function. How can we get real USD into the blockchain? Impossible. It's not possible because real money is not implemented in blockchain. Real money is exchanged in the real world and real financial system. But stablecoin is circulated in blockchain. So two different worlds. So when we develop a stablecoin, our own stablecoin, we have to develop two different parts. One is on-chain part. So we have to write this kind of ERC20 tokens and then deploy this token into the blockchain. And also we have to develop off-chain part. It is traditional part. So we have to develop front end and get money from users and put this money into bank or our storage. I don't know. And then we have to call the smart contract functions. So we have to combine on-chain part and off-chain part. So maybe off-chain part will be very difficult, not easy, because it is about issuing money and getting money and storing money and managing money. So uh, implementing stable coins in blockchain is not that difficult, but doing stablecoin business is not trivial. It is very difficult. Okay, so when you develop a blockchain application, usually you have to develop on-chain part and off-chain part. On-chain part means you have to develop smart contract, and off-chain part you have to build front-end server and database and maybe some blockchain, there's, some big data platforms and machine learning. So these are off-chain part. And then you have to combine these two parts. Okay. Uh, let's see. USDT. USDT is the most circulating stablecoin in real world. 57 billion. Wow. A lot of money, a lot of money. But the code is very simple. Smart contract code is so simple. As I said, you can see their smart contract in a block explorer. They issued their first smart stablecoin in Ethereum. Uh, okay. This is Tether USD, so USDT. And you can see a contract in this page. This is the code of USDT. Safe mass is mass library, ownable to check the owner, and ERC20 basic. They don't use OpenJetPrint because it's old smart contract. At that time, there is no OpenJetPrint standard. So they wrote ERC20 smart contract by themselves and basic token transfer function and standard token is maybe USDT and transfer from approve allowance. Yeah, Tether token. That is the last. So Tether token, inherit standard token and blah blah blah. Transfer from balance of approve allowance. Okay, that's it. Not that long, maybe 200 or 300, but their value is 157 billion. It's very common in crypto space. When you see other code like this, I already put the link of each token. You can see their source code, Pepe. Uh-oh. Uh, the code is not that long, but their market capitalization is so high, maybe billion or hundreds of million, maybe. Yeah, this is Pepe, meme coin. Yeah, ERC20. That's it. So as I said, smart contract code is not that long usually because uh, if you write a long smart contract, uh, gas fee will be expensive, very expensive. So usually, we write very compact code for smart contracts. So very compact and small, very short, but the value is very high. It is crypto and blockchain. Okay. Mm, Okay, you can compile and deploy and run this stablecoin by yourself. Okay, last one. Uh, Up until now, we just use Linux as a simulated environment to deploy smart contract and run smart contract. But after developing and testing your smart contract in Linux, you have to deploy your smart contract in real environment, real blockchain. Uh, the first step is testing your smart contract in testnet. And then after testing your smart contract, you have to deploy your smart contract in production environment, like Base or Ethereum. So in this section, we will deploy our ERC20 tokens into Base Seporia testnet. Okay, we have to change Linux environment. Okay, I choose my token and compile. And then in this deployment tab, we have to change environment to injected provider MetaMask. Before that, you have to check you selected base Seporia testnet. And maybe when you change your Linux environment, the MetaMask will pop up and you have to confirm this Linux service. And you can see the change the environment, the custom 84532. It is the chain ID of base Seporia testnet. So you have to be assured you changed the environment to base Seporia network. Okay, and this is my address, same as MetaMask address. Okay, and we can deploy. Oh, what is the name? JSON token and the string symbol JHT and supply max supply 1 million 1 million. Okay, and then transact. As you can see, MetaMask will pop up, and then I have to confirm, and you have to check this is base Seporia testnet. Okay, and confirm. And success. So as you can see in console panel, we can copy contract address and base. Okay, it is another base block explorer, but I want to change explorer base scan. Okay, and that address. Okay, as you can see, it is contract. So contract is successfully deployed. Contract creator is this address. It's me. Okay, there is no transaction. Okay, and then you can see uh, the functions of this token. So the beauty of Remix is you don't need to develop the front end page for your smart contract. Uh, we can use Remix panel and we can call all functions of a smart contract. So I will mint some amount of token to me. Okay, maybe 20,000 and transact. And I have to confirm. Base separate testnet. Okay. Okay. And then check the Block Explorer. And as you can see, there is a new transaction. Okay. Maybe successfully. Yeah. As you can see, the function is called and with this variable. Let's check my MetaMask. There is no JHT token, so we have to import our tokens with contract address. Contract address is this one, and import contract address. Oh, no, it's my address. So it's wrong. It is not copied. Okay, copied. And is separate testnet. Copy. And automatically the symbol and decimals will be shown. And next. Oh, I I minted 20,000 JHT token, but I just get 0.000 JHT token. What happens? Very small amount of tokens. 0000 blah 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 blah. Do you know why it happens? No, you don't know, maybe. Uh, there is a decimal. There is decimal. We defined the decimal as 18. Why we need the decimal? The secret is here. Secret is Solidity don't support floating and doubles. Floating number. There is no floating number operation. Interesting. When you learn programming language, all programming language has floating number operations, but there is no floating numbers because floating number is not deterministic. So there is a little bit some errors or some missings. So smart contract should be deterministic because smart contract should define some condition, and when the condition is satisfied, it will be executed. So every operation should be deterministic, but plotting numbers may make some errors in smart contract, so they don't support plotting and double. Instead, they applied the concept of decimals. So as you can see, one token means 10 to the 18th. This is the same in smart contract. And we can express zero point 0.5 tokens like this. 10 to 18th, no, 5 and 10 to the 17th. Yeah, that's it. So we can express the decimal the plotting numbers as a decimal, so long integer. So when I when so in remix I put 20,000 tokens, but it is it is not 20,000 because it is very small one in MetaMask, because MetaMask understand decimal is 18. So uh, uh, when we I have to divide this number with 18, 10 to 18th, 10 to the 18th. So it's very small. So okay, so we have to redeploy this smart contract because uh, maximum supply should be larger. And when you develop your smart contract, I suggest you open this kind of converter service. This page will convert the Ether to the smaller unit like Wei or G Wei. So one Ether is 10 to the 18th. So decimal is 18. So if uh, I want to supply 1 million tokens, I have to put this number into Remix. Okay, I will redeploy JH2 token 2 and copy this number. Okay, and transact. Okay, confirm. Okay, success. And uh, this is old one. This is new one. I have 0 tokens, maybe. Balance of 0. So I wanna mint 20,000. So I have to change 20,000. 20,000, and I have to put this number. Amount. Okay. Mint. Confirm. Okay, it's a succeed. So copy contract address and change base scan page. This is new one. Uh, Same code, but new smart contract. And import these tokens. Testnet. Okay. Mhm. Maybe some errors. Okay. JH2. So finally, we can see 20,000 JH2. So it's very confusing. When you're developing a smart contract, we have to consider the decimals, 18s. So every time we convert our number into decimal numbers. Okay, I have JH2 tokens. So I successfully deployed my smart contract into the testnet, and then I minted my token in testnet. And deploying my smart contract to production blockchain like Base, it's the same as the process of testnet. So you just change your uh, network base, okay, base, and also you have to change injected, but it is not changed. But so usually you have to disconnect MetaMask like this, disconnect, and then change the network, okay, and injected provider. So it is maybe uh, hmm, base. Okay, so it is base network. So that's it. The other process are same. So you deployed your contract in base network and test that your smart contract in base network. So uh, in summary, the Remix is a very convenient environment to develop your smart contract. So you have to be familiar with Remix for blockchain development, and then uh, testing smart contract a lot. And if you finalize your smart contract, uh, after finalizing your smart contract, you have to deploy your smart contract into testnet and production environment. Okay, today we we learned how to start Solidity programming and how to use Remix. It's not that difficult. So it is not easy. It is not difficult to start Solidity programming in Linux, but when you develop whole blockchain application, it's not so easy. because you have to use Web3 framework like hard hat and test environment, and then you have to develop front-end site using some library to connect smart contract with JavaScript. So that is very confusing part. So I think I think people use AI engine like Claude Code or Copilot. That AI engine will cover to develop front-end side of blockchain application. But smart contract side, up until now, I think we have to, people, human, have to develop smart contract with the help of AI engine. Because as I said, smart contract is very, uh, we should be very cautious to develop smart contract. So uh, when AI engine develops smart contract, you have to check or you have to audit the smart contract. You shouldn't believe in AI engine because smart contract should be very safe and secure without any bug or vulnerability. Okay, so uh, I finished the beginning of blockchain development. Is there any question? Okay. During the wait for the question, I will take a capture and then check the attendance. Okay, all of you changed your name? Okay, good. Okay, it is very convenient way. Okay, 1, 2, 3, 5, 19. Maybe some students dropped this class, so I think maybe 20 plus will continue to this class. So it's good because uh, this class I will give many chances to experience Web3 and crypto and blockchain, and I will help you to finish your assignment and your project. So if you need some help or if you want to discuss about your project or your assignment, anytime you can contact me. If you contact me via email, I will have, I can make Zoom sessions or I can advise your problems or your proposals, your project. So I wanna get a real experience. I wanna give you a real experience about blockchain and crypto. And uh, if possible, I wanna connect you to other people in crypto and blockchain space. So if you make some efforts to finish this class, you will get some experience and some connection to crypto space on blockchain space. Okay, no question. in the next class, I will ask you some question, so you have to answer. Okay. And next part is uh, I finished one of use case in order to show you some examples of your report. So today I will uh, I will explain my report to you, and then from the next class you have to present your report to students, so you can refer to my case. Okay. Okay. I will share the screen. Okay. Hmm. Hmm. I created course website again. Uh, Previously, I developed this course website with vibe coding, but it failed. So I rebuilt course website with some tools like GitHub. Actually, this is GitHub page, and also I used Markdown to make document, and also MKDocs convert Markdown to HTML with Google GitHub Actions, and HackMD is the user interface for creating Markdown document easily. So I combined this service and then created this website. So I uh, I created the report about Glass. Anyway, Glass is a decentralized web crawling network. So week 4, we will handle decentralized AI infrastructure. So I researched Grass as a reference. So this is the report about Grass. So I will explain what Grass is in maybe 15 minutes. 15 minutes. And as like me, you have to write your report like this and then present your report in this class. Okay, this is HackMD interface service. This is editor window, and this is viewing window. This is Markdown grammar. So when you write something, you can see the result in this viewing window like this. This is the title. Hmm. Uh, it is a little bit slow. Okay. So uh, it, after this lecture, you have to select your the case study, and then you have to write this kind of report by yourself. So I will share the template MD file, markdown file to you, and you will access this MD hack MD service, and you have to write these things, and I will sync this document to GitHub site. you can access this site, and anyone can access this site. Anyone can see this site. So when you write your report, anyone in the world can see your report. So I wanna promote anyone in crypto space or blockchain space see your report. And then if you write your report well, someone can contact you for asking something or for proposing something. So I wanna give you some opportunity to connect to real people in crypto space, in blockchain space. Okay. Uh, Grace. So I will start my presentation as a reference in 15 minutes, and you have to present like me. Okay. Okay. Let's start. Grace. Grace is decentralized web crawling network. This network is leveraging idle internet bandwidth of normal users. Everyone has their own laptop or smartphone. So if if you install their program, Glassnode, this node will run in your computer or in your smartphone. And then that node will crawl the public internet and then collect that data, and this data will be sent to the validator of Grass network, and then this data uh, and Grass Grass will sell this data to AI companies because AI companies need a lot of data, especially latest data. You recently when you use ChatGPT or Claude, searching the web and then combine and then understand those data uh, and then output the result. So even though we have some new model transformer, so we can do unsupervised learning, still we need latest data. But the fact is, web crawling is not that easy. You can see the status of web crawling industry in section 2, state of web crawling. Many websites don't want to be crawled, don't want to be corrected by uh, crawling bots or crawling companies. So, as you can see, 43% of sites are 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 employing bot defense technology, like there are many bot defense technologies like this, uh, Cloudflare, CAPTCHA, and IP restrictions, and blah blah blah. And also, many websites, many websites stopped crawling from data center IP. So, uh, if centralized web crawling companies do this job, they have some risk to stop their crawling by restricting IPs. So Grass idea is, what about using users' computer? Because users has their IP, it's not data center IP, it's residential IP. So if the company like Grass send some request to crawl some data, my computer will relay that request and get the result and return that result to the company. So it is crowdsourcing of users' computers' idle resource, in this case, internet bandwidth. I think it is very suitable to use crowdsourcing schemes for service. Yeah, okay. And how it works? Uh, Actually, they are doing well. Currently, they have 3 million, over 3 million nodes in the world in 190 countries. So a lot of nodes are learning to crawl the public webs and collect data. Actually, they, sorry? Okay, okay. So, actually, they started this business last year. So, in 1 year, they gathered over 3 million nodes in the world. So, it's very impressive. These are architecture. Uh, they have two different parts. It is crawling part, and the other is proving part. Crawling part consists of validator and router and Glassnode. Glassnode is the software program installed in user computers, and validators validators will get some request from client like AI companies or other companies. So that other companies request some crawling to validator, and validator choose some router. Router is geographically distributed. So if router get the request, router choose a grass node to correct that request, that web data. So after correcting web data, this data will be sent to validator, and validator validator will make some proof, and then this proof will be written in blockchain. Actually, validator, router, Glassnode, these are not blockchain. These are typical software running in computer or servers. But when validator get the result of web crawling, they make some proof. This proof is about this answering, this response, or this process is correct. And then make the proof with GK nairis. GK is zero nairis proof. It is cryptographic technology to protect privacy. And then make some proof and write this proof into blockchain. They use Solana. So put this proof into Solana. So any client check this request is correct in the blockchain. And also, validator write some the data provenance into blockchain. The provenance means the source, data source is correct, and also the paths of data into blockchain. So whenever client want to see the data is correct, or the web crawling process is correct, they can check in the blockchain. So that is why they apply blockchain technology. So you can see other part of report, and they have token. The token name is Grass. I think in this case they need a token because they have a lot of users who are learning Grass nodes in the world. And I installed my Grass node in my computer. So they have many users in the world. How can they return their uh, rewards as a cash or as a card? In traditional financial system, it is totally difficult. If let's assume if there is an user in Uganda, how can you verify the user is legal? And also, how can send a small amount of money to Uganda users? It's very difficult, so difficult. So token is very suitable for crowdsourcing service. When they when I install and running their software Glassnode, I will get the rewards as their token. And then if I want to change their token to money, real cash, I can send this money to this token to exchange and then get real money. Okay. Mm, there is the concept of TZE. TZE means token generation event. Usually, crypto project and blockchain project, when they start their business, initially they don't have tokens. Usually, they build some service or platform, and also they will get some fund from investors, VC, and then maybe 1 years later or 2 years later, they will issue their token. They generate their token. So it is called TZE. And they did TZE in October last year. Okay. And we can see their token status in coin market cap like this. The price is 0.97 USD, and total supply is 1 billion grass. But currently uh, currently circulating supply is 243 million grass, maybe 24% of total supply is circulating. Other tokens are not minted or other tokens are locked in some contract. So it is not circulating. So when we calculate the market cap of token, we usually multiply circulating amount of tokens and the price. So their market cap is this is 237 million. And uh, yeah, that's it. So you can understand this information like in coin market cap. Okay, this is token allocation and circulating supply schedule to 70 months. And when they start their service, they did airdrop to early adopters, 10% of their total supply. So 0.1 billion. So 1억 개. And their token economy is very interesting because they have two-step token system. When you run their node, like me, this is their service, and this is dashboard. I run their program, installed their program uh, yesterday, and I run their program 2 days, and I get 3,000 blah 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 point, not a token. It is not a token, point. And then this point will be exchanged to the token in proportional to the amount of points. The time is the end of epoch 9. So it is the way they are designing their token system, token economies. Okay. So every day they are collecting over 800 terabytes of data, web data. So it is not small, so very big. And they are continuously upgrading their software, and uh, in near future they will release specialized hardware to crawl web. So if I buy this hardware and connect this hardware into Wi-Fi, this hardware will correct, and I will reward it as a token. It is kind of minor, grass minor. My user experience was good because it is very easy to install and learn their software. Just install and turn on their software. That's it. And they provide dashboard service, and I can see my status and my earnings like this. And as you can see, they have very strong referral programs. If you invite your friends, you will get additional rewards. If your invitee will learn your software, this software, maybe the first referral, primary referrals. In case of primary referral, we will learn 20% of 20% of invitees earnings, and you can earn second referrals earning. So 10% and 5%. It is kind of pyramid structure. So if you invite more friends, you will get more points, and they have tiers. So you have to, if you want to get more rewards, you have to break the tiers. Kind of quest. Okay. Uh, so why we need a blockchain for this kind of service? Uh, when I see their service, the first need is token. As a reward, token is perfect fit for crowdsourcing in the world. So before this kind of service, we have similar service like SETI at home or folding at home. It is called volunteer computing. So my research topic was volunteer computing. So anyone, if you install that kind of software for volunteer computing, screensaver will work for for finding out some signals or analyzing proteins, but there is no reward. So it is volunteer. But in this case, it is commercial purpose. So we have to get reward. As a reward, token is perfect for crowdsourcing. So blockchain is needed, required for issuing tokens, and also the transparency, because clients have to believe in the provider, like Grass company. But the validator writes some proof of recurring. They don't need to contact to the company. They just check in the blockchain, and then they can see, oh, the data is right, or the data provenance is correct. Okay. So I think their token economics very interesting, and it is working in my thought. But I think the price is volatile. So when if I running this software in 1 month, maybe the end of July, I will get their token. Uh, but the total price, the total earning is volatile with their price of tokens. So after 1 month, if I get 1,001 or 1 USD, I will stop this program because it is too small to run this program. So I think we need some way to hedging the volatile of token price. So yeah, it is my idea. And I wrote a lot of my opinion about some limitation of this service, and some suggestions. You can read this my opinion. And if I have time, I wanna discuss some questions about this service like this. Okay, I spent 20 minutes. Maybe from the next class, I will give you maybe 15 or 20 minutes for your presentation. So you have to prepare your report like this, and then you have to present. So I will introduce how to write this report, and how to send me the report uh, via email. But before that, you have to choose one use case. Okay, I will I will open the Google spreadsheet to choose a use case. Maybe tonight, maybe 10 o'clock. 10 o'clock. So it's first come first serve. So if you want to choose your some specific use case, you have to be hurry to write down your choice. Okay. hmm Okay. Uh, this is a kind of reference for your presentation. So, from next class, you have to present this kind of use case. And then I'm thinking about some group discussions about each use case, and then we come together, and we will share the group discussions. So I will announce that kind of style of lectures uh, through email. Okay, any other questions? Mm-hmm. Okay. So, I will send you the guide of your report assignment and project through email. So, uh, from the next class, um, I expect you are presenting the use case. Okay. Okay. Thank you for attending the class and see you the next time.